So in the first 6 problems, our goal is to go ahead and simplify the expressions. So the first one, we're just combining like terms, okay? So you basically highlighting the ones that have the identical variable expressions, right? So 8x squared, there's no other x squared, so we bring it over. Okay, then negative 3x plus 9x is going to give you plus 6x. And then negative 2 minus 5 will give you minus 7. Okay, so the next one, 4 times 3x will give you 12x. 4 times negative 2 is minus 8. Okay, number 3, negative 3x times 2x gives me negative 6x squared. Negative 3x times 4 will give you minus 12x. Next, first thing we want to do is distribute here. Okay, so 5 times 2x is 10x minus 15, right? Then plus 24x, and then plus 6. So now when I combine like terms, 10x and 24x will give me 34x, and negative 15 plus 6 will give me minus 9. Okay, so next, this is a FOIL problem, so we're going to multiply first terms, x times x is x squared, minus 7x plus 3x minus 21. And that will give me x squared minus 4x when I combine these middle terms, minus 21. The last example here, 2x times 3x is 6x squared, minus 10x minus 3x plus 15. And when we combine these two middle terms, we get 6x squared minus 13x plus 15. So when you simplify expressions, you're basically, looking to distribute, combine like terms, and you are done. The next one, evaluating functions, right? Remember, the letter in front is the name of the function, right? The number inside, right, or the variable inside is your input value. So when I go to evaluate g of 4, it tells me I'm going to use this function here, right, g of x, and everywhere I see an x, I'm going to replace it with a 4. Now, that would give me 4 times, I have to do exponents first, 2 to the 4th is going to give me 16. 4 times 16 is 64. Now, h of 3, since I'm using function h, I'm going to use this function, and everywhere I see an x, I'm going to replace it with the 3. So 2 times 3 squared minus 3 times 3 plus 5. So this is going to give me 9 times 2, which is 18, minus 9 plus 5. 18 minus 9 is 9, and 9 plus 5 will give you 14. Okay, number 9. Now that I'm taking f of 3 and adding g of 1. So the first thing I want to do is evaluate f of 3. So I'm going to go to this first function and plug 3 in for x. Negative 2 times 3 minus 3 plus 4. This is going to give you 0. Negative 2 times 0 is 0. So f of 3 is 4 plus g of 1, right? When I plug 1 in for x there, 4 times 2 to the first power, 4 times 2, which is 8. All right. Now, the next one. What you have to remember here is we have an explicit, a recursive, and a linear, exponential, and quadratic function. So all of the functions given here are the explicit version. You need to determine if it is linear, exponential, or quadratic. So right away when I look at this one, this is in the form a times b to the x power, which you have to know is exponential. Okay, Now your initial value would be 0, 4, because that's A. Your common ratio is going to be 3. Therefore, we're going to say f of 0 is 4. Then f of x equals, since the common ratio is 3, we're going to do 3 times the previous term, which is f of x minus 1, and that would be a recursive rule. The next one, right away when I look at this, I'm going to simplify this and say that this is x squared plus 4x. And remember, anything in the form ax squared plus bx plus c is a quadratic function, right? Now, we are not going to worry about this one, so we're just going to put not applicable. We could do it, but we didn't really talk about it. However, the next one, right, this is in the form m times x minus x1, all plus 4. So right away you know that this is linear. And the recursive rule, right away when I go to look at my ordered pair that's given to me, right, since I take the opposite of this, it's going to be 1, 4, and my slope is -9. And remember, that's also, right, your common difference. So we're going to say f of 1 is equal to 4, then f of x is equal to f of x minus 1, all it should be minus 9. Okay. So the next one, use the graph of Gulliver's distance from d of t with respect to time in hours t, right? Use the graph to answer the following questions. So d of 4. So if I input 4, meaning time is 4, okay, what is the output? Well, when t is 4, my output is 5. How long does it take him to get 11 miles from home? Well, here's 11 miles from home. How long did it take him to get there? It took him 5 hours. How long did it take him to get home after he reached his destination? Right? So when we look at it, if he reached his destination here, right? How long did it take him to get home from here to here? Well, that's going to be 1 hour, 2 hours, 3 hours, 4 hours, about 4.5 hours. Okay? And interpret d of 3. What this means is if my input, right, is 3, t is 3, d is 4. So after 3 hours, he traveled 4 miles. Okay? Right here, if I look, what do I notice here? Right away, I notice that I'm going up 6. Here I went up 10. Here I went up 14. Now, there's no common difference. There's no common ratio. So now we look for that second common difference, right? So this goes up 4. This goes up 4. So right away, if we have a second common difference, if this happens, that tells us this is quadratic. Okay? So when you look at this, if you don't understand how to do the explicit recursive, the next chapter we learn this a much easier way. So I'll just give you the explicit is 2x squared plus 3. Remember, you're basically multiplying this squared. So 2 times 1 squared will give you 1 times 2 is 2. What do you have to do? Add 3. Okay, so it's kind of like trying to figure out the pattern of what can I do to the x term. You know it's quadratic, so it has to be x squared something, right, to get this. Okay, and don't worry about the recursive for a quadratic rule. So the next one, if I look, I know Here I'm going up 6. Here I'm going up 20. Here I'm going up 18. If I look, I'm multiplying this by 2, but that times 2 doesn't give me 32. So right away here, there is no pattern. Okay, so keep that in mind. All right. Here, I'm going up 2, up 2, up 2. So right away I know that this is a linear function. And right away, if I look, they give me the y-intercept. So the explicit rule should be real easy. So it's going to be f of x equals, remember, you're going to use mx plus b for this one. So it's just going to be 2x plus my y-intercept is 6, so plus 6. My recursive rule, f of 0 equals 6. Then f of x equals f of x minus 1. And what are you doing each time? Adding 2. Here, what am I doing each time here? I'm multiplying by 3. So right away, I know that this is an exponential function because it has a common ratio. Now my explicit, remember, for an exponential, it's a times b to the x, where a is your initial amount, which is 3, times my common ratio is 3, so it's 3 to the x power. And the next one, f of 0 equals 3, f of x equals f of x minus 1, all times 3. Okay? So here it says, toothpicks were used to create the following diagrams below. Determine if the number of toothpicks used in each stage represents a function that is linear, exponential, or quadratic. Then use the pattern to answer the questions that follow. So here I have 3 toothpicks. So in the first, I have 3. In the second, I have 1, 2, 3, 4, 5. In the third, 1, 2, 3, 4, 5, 6, 7. And in the fourth, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in the fourth, there's 9. So what do I notice is going on here? It's going up 2 each time. So right away I know that this is a linear function. The recursive rule would be f of 1 equals 3. Then f of x equals, my common difference is 3 or 2. So it's going to be the previous term plus 2. My explicit rule, I'm using the ordered pair 1, 3 and the slope of 2. So f of x equals 2 times x minus 1 plus 3. And how many toothpicks would there be in stage 5? That would be 11.